Hi everyone. In this bite-sized bit, we are going to explore exception handling in C#. Let's go ahead and get started. The way I like to think about exception handling in C# is like the airbags in your car. If you do everything right when you're driving your car, you're very careful, you check your mirrors, you drive the speed limit, you use your turn signals, you should never need your airbag. That said, you certainly want an airbag in your car in case something that you weren't expecting ends up happening. That's the way we're going to treat exception handling. Ideally, we are going to write code that will never need exception handling, but we're going to include it in case something unexpected occurs so that we as the programmer can handle the errors as opposed to letting C# handle the errors automatically. I've created a very simple example in C#. In this case, I'm going to collect two numbers from the user, and I'm going to divide the first number by the second number and report the result. So the simplest of math. The reason why I'm choosing this problem is because division allows us all sorts of different potential errors. It's possible the user forgets to enter a number in one of the two text boxes, or they type something that isn't a number in one of the two text boxes. It's possible the number that they type in one of the text boxes is too large. It's possible that the number they type in the second text box is a 0, and division by 0 is impossible. And it's possible that something else completely unusual happens. And so this gives us a great opportunity to explore all different types of errors and respond to them using the error exception handling techniques that we have available to us in C#. Let's take a look at our code. You can see I've already done our input and processing and output, and it's very straightforward. What we're going to do is we're going to add some error capturing techniques so that anywhere an error could occur, we can interrupt with our own programmer response as opposed to letting the code respond itself. As a reminder, the way the code responds is not necessarily beneficial to our end user. So for instance, if I run this program and I don't type anything, and I click my divide button, I immediately get a format exception error, and the code stops, and the code is revealed to the user. And this is not a scenario that we want. So we want to prevent this sort of situation from happening and respond in our own way to errors that occur in our code. The first thing that we're going to do is add a try block to our code. So we are typing the word try. We're typing in an open and close bracket. And then we're putting anything that could potentially cause an error inside the try block. In my case, I'm taking all of my code, input, processing, and output, and putting it inside the try block. I don't know if the error is going to occur when I do conversion. I don't know if the error is going to occur when I do my division. I don't know if the error is going to occur when I try to output. And it doesn't really matter. This is an airbag. It's there to protect the user from any kind of crash, regardless of why the crash occurred or when it occurred. So we're going to put everything inside our try block just in case something goes wrong. After the try block, you have to have at least one catch statement. And a catch is how the code responds to an error. I'm going to add the most generic of catch blocks, which is just the word catch with nothing else, and then an open and close set of braces. So this is going to capture every single error regardless of what type of error and what caused it, and it will then respond with whatever I put inside these brackets. Not the built-in response that C# has, but now my programmer response to an error that's occurring. So in this case, since I don't know what kind of error actually occurred, I'm just doing a very generic message box show that tells the user an unexpected error has occurred, please try again, and titling the message box error. If we run our code and purposely cause an error to occur by not filling anything in, the response isn't the automatic response we would have seen before. It's now our own custom response, an error message that says an unexpected error has occurred, please try again, and when the user clicks OK, they're returned to the form. This is much better than our code being halted and revealed to our user. So we've already made a significant improvement to how we handle errors. it is possible for us to respond slightly more specifically to the kinds of errors that are happening. We wrote the most generic of catch responses, but we can add specific catch responses to errors that we are potentially anticipating. The more specific the error, the higher in the list of the try-catch block it has to appear. So we can keep our generic catch at the bottom of the list, and above it we can add some more specific catches. One of the most common catches that we might be interested in are format exceptions. This is where we try to convert something from one data type to another. For instance, we're trying to capture something from a text box and convert it to a number, and that conversion fails. That could happen, in our case, in either of our two input statements where we're trying to convert to decimal. If either of those things occurs, we know that the user typed something that wasn't numeric. So I can add a message box that responds accordingly. This message box tells the user to please enter numeric values for each text box. So this is more precise in terms of telling the user what they've done wrong. If I run our program again, that specific error is what happens first. The user didn't type anything inside the text box, so we're seeing a format exception error, and we're telling them please enter numeric values for each text box. Similarly, if they typed letters in the text box, we would see similar results. We would encounter the same error even if the user typed something that made sense for the first box, like a number, but still managed to botch the second box. As the try block moves from one line of code to the next, if any error occurs, it moves the cursor to the catch block and responds with the appropriate message box. What would happen if the user did type numbers in the text boxes, but we still caused another error? So for instance, in the second text box, I'm going to type a number, but it's going to be absurdly large. So I'm just holding down my finger on the 9 key until I get a really, really big number. This isn't going to cause a format exception error, but it's still going to cause an error. In this case, the number is way too big. The format exception error wasn't triggered, but my overall catch block, my kind of catch everything, still got triggered, and I see my unexpected error has occurred. Please try again. Could I add a more specific catch block for really big numbers? Well, let's try. The type of error that happens when the number is too big is called an overflow exception, where the number is overflowing the data type. So I've added a catch overflow exception and added a message box that asks the user to type smaller numbers when this occurs. Let's see what happens when I enter a number that is too big in either of my text boxes. So I'm going to again hold down the 9 for a while, so I make sure I have a really big number. When I click divide, I'm now going to get an error that I should enter smaller numbers in my text boxes. Note, I didn't even get to the second text box, which is empty. The first text box caused an error, specifically an overflow exception, and so the catch block was triggered for overflow exception, and the message box for overflow exception shows up on our screen. Other types of error messages you might include would be division by 0. If I add a catch divide by 0 exception block with an appropriate message box telling the user you can't divide by 0, that will protect us from that sort of error. So if I type 32 divided by 0, I'll get that specific message. Could other types of errors occur above and beyond format exceptions or overflow exceptions or divide by 0 exceptions? Maybe. I don't have a crystal ball and I can't think of every single possibility. But I do have a catch block at the end of my specific catches that will catch any other type of error that I'm not anticipating as the programmer. So we have specific airbags to prevent specific types of crashes from occurring, and we've got generic catches to prevent generic errors from occurring. And at this point, the user could never break our code to the point where we wouldn't respond with a specific error message. That's it for this video. Thanks so much for watching. See you next time.